In the following example, I'm going to try and predict the redox reaction that's going to that's probably going to take place between copper and FeCl3 aqueous. Now, step 1 involves that the first thing that you need to do is you need to identify your reactants. So it's pretty obvious that you have copper and FeCl3 aqueous, but remember, when you're figuring out the redox reaction, you have to go into a lot more detail and figure out which ions are involved as well. So you have copper, that's one of your reactants. So I'm going to write that down. I'm going to try and identify my reactant. So one is copper. The other reactant is, if you look at FeCl3, now FeCl3 is composed of two ions. And they would be in dissociated form because it's in aqueous state. So remember, in aqueous state, FeCl3 is not going to be a compound, it would be dissociated. And there would be two ions present in FeCl3. One would be Fe3+, so that's one of your reactants, and the other one would be Cl-1. So that is our first step, and we have figured out that we have three reactants. We have copper, we have Fe3+, and we have Cl-1. Now, one of the species in these three would be the one that would be gaining electrons. There would be another species between these three that would be losing electrons. So now we're going to move to the next step and try and figure out which substances are the ones that are losing or gaining electrons in these three reactants. So moving to step 2 now, we now have to write down all electrode reactions involving the above species. So we have copper, Fe3+, and Cl-1. Now I'm going to refer to the data booklet, and I'm going to try and find out all the electrodes that involve these three species. So let's refer to the data booklet. So I'm going to look for electrodes that involve copper. So you can look at the electrode over here. There's one electrode over here, and there's another electrode over here that involve copper. So let's mark these two electrodes. These two electrodes involve copper, and I'm going to write them down because copper over here is in equilibrium with copper 1+, and the electrode potential is given as 0.52 volts. And then there's another electrode that also involves copper, and that's in equilibrium with copper 2+, and that has an electrode potential of 0.34 volts. I'm not going to write this electrode over here because I only need electrodes that have copper in them, because our reactants, they contain copper. They don't contain copper 1+ or copper 2+. I'm only going to figure out or write down those electrodes that contain copper. If you look at this electrode over here, this also has copper, but over here copper is reacting with ammonia. I don't have ammonia in my reactants, so I can't write this. So this I won't be using this electrodes because I don't have ammonia in my reactants. So make sure you select the electrodes that contain copper and only copper, or any of the reactants that are already present with you. So I've written down the two electrodes, copied the two electrodes from the data booklet. I'm going to move to Fe3+, that's my other reactant, and I'm going to refer to the data booklet now. Now, finding electrodes that involve Fe3+, I've already figured out these two electrodes over here, where Fe3+ is gaining 3 electrons to form Fe in equilibrium with Fe, and the potential is electrode potential is minus 0.04 volts. The other one is Fe3+ plus electron in equilibrium with Fe2+, and the electrode potential is 0.77 volts. So I'm going to select these two electrodes because they fit our reactants. There is no other equation where Fe3+ is involved, so I'm going to pick these two electrodes that contain Fe3+. Lastly, so I've written the electrodes that have Fe3+ involved in them. Lastly, I'm going to look at Cl-1. This is my third reactant, so referring to the data booklet back again. So you can look over here. There's one electrode that has Cl-1 in it. So I'm going to select that. It's basically Cl-1 in equilibrium with. So this is Cl-1 in equilibrium with Cl2. So Cl-1 would be losing electrons, Cl2 would be gaining electrons there in equilibrium, and the electrode potential is given as 1.36 volts. There's another equation as well that has Cl-1 in it, another electrode that has Cl-1 in it, but I'm not going to select this electrode over here. The reason being that it also needs OH-1. Remember, our reactants, there was no OH ions in our reactants. So if I'm going to select this electrode, then Cl-1 needs OH-1 for this equilibrium to be established. So I won't be able to actually select this electrode, it doesn't apply to my reaction. So there's only one that I'm going to select, which is this one over here. Now I've written all the electrodes that were relevant to my reactants. Remember, I had 3 reactants. One was Fe3 plus, I had copper as a reactant, and I had Cl minus 1 as my reactants. So I wrote down all the electrodes involving these 3. Now I'll move to step 3, which is that step 3 is the rule in electrochemistry is the higher potential always has a tendency to get reduced. So higher potential is going to gain electrons, whereas the lower potential is going to get oxidized and it's going to lose electrons. And I need to make sure that the reactants are present in the reaction. I have 3 reactions, Fe3 plus, copper, and Cl minus 1. So if anyone gains or loses electron, it's going to be any of the 3 that are shown over here. These are my reactants. So I'm going to first pick higher potential, which one has the highest potential, because that's the one that's going to get reduced. That's the one that's going to gain electrons. So if you look at the 5 electrode reactions that I have given over here, you would notice that the highest potential is shown by the last one, 1.36 volts, which means that this is the one that I would select. This is the potential that's, because it has the highest potential, it's the one that's going to gain electrons. And for it to gain electrons, this reaction must go in the forward direction. Because in the forward direction, this electrode reaction gains electrons. So the highest potential gains electrons. But now there's one problem, and that problem is, for this reaction to be selected, this is the highest potential, so I have selected it, but for it to gain electrons, it must go in the forward direction. But for it to go in the forward direction, it's chlorine that is the reactant that should be gaining electrons. But I only have Cl minus 1, I don't have Cl2. So I won't be able to fit this reaction to my reactants over here. This equation does not fit what my reactants are over here. So Cl2 would not be able to gain electrons to form Cl minus 1 because I don't have Cl2 in my reactants. So what I'm going to do is I'm going to just remove and cut this equation out because this equation does not fit with my reaction. So I've simply removed that equation and I'm going to go to the step 3 again. Higher potential is the one that's going to get reduced. So again, finding which one has the highest potential, it's coming out to be 0.77 volts. So this is the one that's going to be gaining electrons. And for it to be gaining electrons, this reaction must go in the forward direction. And if you look at this reaction now carefully, highest potential gains electrons, so it goes in the forward direction. Fe3 plus is the one that's gaining electrons to form Fe2 plus. And my reactant now is Fe3 plus in this particular electrode, and I have Fe3 plus as one of my reactants. So this equation fits perfectly with my given reactants. So out of these 3, it's Fe3 plus that has the highest tendency to gain electrons and form Fe2 plus, and the E0 is 0.77 volts, which is the higher potential. So I've selected this equation. This is the reaction that's going to go in the forward direction. It would be gaining electrons. Now I'm going to focus on the other part, which is that the lower potential is the one that's going to get oxidized or it's going to lose electrons. So lower potential is the one that's going to get oxidized, and out of the remaining 3, I'm going to figure out which one has the lowest potential. And this comes out to be this third reaction over here, this third electrode over here. This is the one that's going to get oxidized. And for it to get oxidized, it must be losing electrons. So it must go in the backward direction because that's the way it's going to lose electrons. So if it wants to lose electrons. So minus 0.04 volts is the lowest potential. And therefore, Fe is the one that should be losing electrons. But now we have a problem again. And that problem is that I don't have any Fe in my reactants. My reactants has Fe3 plus. So I don't have Fe. And since I don't have Fe, it's not possible that Fe would be the one that would be losing electrons because there is no Fe present in my reactant. So again, this equation does not fit with my reactants given over here. And what I'm going to do is I'm going to cut this equation out. It does not match my reactants. So removing that equation, I'm left with these 2 equations. Lowest potential is the one that's going to lose electrons. It's going to be this one. 0.34 volts is the lowest potential. So this one would be losing electrons. So copper is the one that would be losing electrons. If I select this, it would be going in the backward direction to lose electrons. And copper would be my reactant then. and I have copper as one of my reactants in the reaction. So I would select this equation because copper is present as one of my reactants. Similarly, Fe3 plus was the one. So Fe3 plus is the one that's gaining electrons to form Fe2 plus. Copper, on the other hand, is the one that's losing electrons to form copper 2 plus. So the reaction is happening between Fe3 plus and copper. And I'm going to remove the rest of the equations now. The step 4 that we're going to do now is we're going to try and write the overall reaction. And before that, we need to balance the number of electrons that are being gained. So if you look at the two equations I've selected for oxidation and reduction, Fe3 plus is the one that's gaining electrons to form Fe2 plus. Copper is the one that's losing electrons to form copper 2 plus. The number of electrons lost are 2 electrons. The number of electrons being gained is just 1. So to balance the number of electrons lost and the number of electrons gained, I would have to multiply this entire equation by 2. So I'm going to multiply this entire equation by 2. If I have 2 Fe3 plus, then 2 electrons would be gained to form 2 Fe2 plus. So if I multiply this entire equation by 2, the number of electrons lost and the number of electrons gained are now equal. Now the next step is I just need to simply add the two reactions up. I'm going to add the reactants. My reactants are, in the first equation, the reactant is Cu, and in the second equation, the reactant is Fe3 plus and 2 electrons. So I'm going to add them up. It's going to be copper plus 2 Fe3 plus 2 electrons. And now I'm going to look at my products now. My products are going to be, in the first reaction, the product is Cu2 plus 2 electron. In the second reaction, the product is Fe2 plus. So I'm going to add the two up. It's going to be Cu2 plus 2 electrons, and the other product is 2 Fe2 plus. And now I have this overall reaction with me. The number of electrons that are being gained and the number of electrons that are being lost would get cancelled out. So remove that. If I remove that, then I'll have my overall equation. It's going to be copper plus 2 Fe3 plus forming copper 2 plus and 2 Fe3 plus. So copper is the one that is getting oxidized. Fe3 plus is the one that is getting reduced. Moving now to step 5, which is that we need to find the overall E0 cell, the cell potential, which is basically higher potential minus lower potential, or the reduction potential minus the oxidation potential. So we are going to go back to our two reactions that we selected, two electrodes that we selected. This was our reduction potential, or the higher potential, 0.77 volts. This is my lower potential, 0.34 volts. Subtracting the two values would give me the potential difference, or the E0 cell. So it's going to be 0.77 volts minus 0.34 volts, and the value comes out to be equal to 0.43 volts. So this is my overall E0 cell. And remember, the greater the E0 cell, the faster would be the reaction. That means the potential difference between the two electrodes is going to be very large. So electron flow would be faster and the reaction would be faster. So the higher the E0 cell, the faster the reaction is going to be.